One of the things in lesson 13.3 we're going to be asked to do is to evaluate the 6 trigonometric functions of theta. So that's what we're going to start off with. So I drew a right triangle in the circle. You can see that I have the base labeled as x because it's on the x-axis. The y is vertical, and then the hypotenuse is r, and that would represent the radius. I also made sure to include my little cheat, SOHCAHTOA, or Oscar had a handful of apples. So we're asked to find sine theta, and theta is always going to come from the origin. All right, so we know that if we're coming off of theta, opposite over hypotenuse is going to be y over the hypotenuse of r. Cosine theta is adjacent, so adjacent to theta is x, and the hypotenuse is r. And then for tangent, it's opposite over adjacent, so y over x. Then if you remember, for cosecant, secant, and cotangent, it's just the reciprocal of these three. On the left-hand side of your screen, I said, well, let's look at a unit circle specifically. So the blue triangle is one way we could draw a triangle. We have our x, our y, but remember with a unit circle, r is equal to 1. So instead of r, we would label it 1. Let's look at the red triangle. Again, we have x, we have y, and the hypotenuse is 1. So if we go down to our sine theta, cosine theta, tangent theta, instead of the denominator being r, it's going to be 1. So it's y over 1, and we know that that's just equal to y. Here for cosine, remember we said it's x over r, but r is equal to 1. So x over 1 is just going to be equal to x. And then for tangent, it's just y over x. And then again, we end up putting our reciprocals for cosecant, secant, and cotangent. So in this first problem, we're given the ordered pair -7, 2, and we're asked to find the 6 trigonometric functions of theta. So if x is equal to -7, that places a point over here. And it says that y is equal to 2. And remember, we're coming off the origin because that angle is theta. So our triangle is going to look something like this. In this instance, we were not given the hypotenuse or the radius r. So over on the right, I used my Pythagorean theorem and found out that r is equal to square root of 53. Now we can start looking at our sine theta, cosine theta, etc. All right? So we're coming off of angle theta, and it says we're finding sine, so that's opposite, which is 2, over the hypotenuse, which is the square root of 53. And if you remember, we need to rationalize that denominator, so we're going to multiply by square root 53 over square root 53, and that gives us 2 square root 53 over 53. Cosine says we have adjacent over hypotenuse, so the adjacent side, we have -7 over the hypotenuse square root 53. Again, we need to rationalize the denominator, so we should end up getting -7 square root 53 over 53. Yay, so finally we have an easy one. We have opposite over adjacent, so we end up with -2/7. And we don't have to do anything with that one. All right, so now for our cosecant, secant, and cotangent, you just need to write the reciprocals of what we have. So if I go to our original, it's okay to have the square root 53 in the numerator, so it's going to be square root 53 over 2. Again, we can go to our original answer before we rationalize, so we end up with negative square root 53 over 7. And for the last one, it's just negative 7 over 2. All right, I would like you to pause the video and give this one a try. So you're starting off with your ordered pair, negative 9, negative 40, and you're going to try to determine the 6 trigonometric functions. So in the upper right-hand corner here, I have the steps which I followed. The first thing I did was I drew my triangle. I wanted to make sure that I had a leg that was on the x-axis. I was sure to include theta at the origin, and I made sure to include my sines. The next thing we needed to do was calculate r by using our Pythagorean theorem, and once we had all 3 sides, we simply used SOHCAHTOA. And then for the second column, we just wrote the reciprocals of each of the values on the left. So in the next section, so here we were given the ordered pair and asked to find the 6 trigonometric functions. In the next section, we're going to be asked to find the 6 trigonometric functions, but we are going to be given the theta. All right, so just a reminder that a unit circle has a radius of 1. And we looked at this in a previous lesson. We said 180 degrees is equal to pi, and a full circle, 360 degrees, is equal to 2 pi. Also on an earlier slide in this lesson, we determined that when we're using a unit circle, that sine theta is equal to y over 1, or just y. Cosine is x over 1, or just x. And then tangent theta is y over x. All right, so we're going to keep that in mind, and we're going to go look at this next problem, which asks us to evaluate the 6 trigonometric functions of theta equals 2 pi. Because we're dealing with a unit circle, and remember down here we said sine theta is equal to y, and the radius is 1, so this ordered pair is 1, 0, so y is equal to 0. Cosine is equal to x, and x in this instant is equal to 1. And then tangent says it's y over x, so that would be 0 over 1, which is the same as 0. All right, so now we're going to be dealing with the reciprocal of these. All right, so let's go back down to our little key down here. So we said sine theta is equal to y, but it starts off as y over 1. So it would be 0 over 1, but then we write the reciprocal, so that is equal to 1 over 0, and we know that when we have a 0 in the denominator, the answer is all actually going to be equal to undefined. All right, so now we're going to go to secant theta. So we'll go back down to our key. So it would be 1 over 1. And we know 1 over 1 is equal to 1. And then for cotangent, the reciprocal of 0 over 1 is 1 over 0. So again, our answer here is going to be undefined. You can look in your textbook for another example. They have one where theta is equal to 270 degrees if you want to see one more, but we still have one new concept to look at. So here we're going to find the reference angle, and the reference angle is the angle that makes it back to the x-axis. So back to x-axis. And we're going to start with 875 degrees. All right, so we're gonna start our circle. We go 360 degrees, but remember we need to go a total of 875. So we're going to continue on, make another circle. So we just added on another 3/60, so that gives us 720. So 875 minus 720 20 is going to give us 155. So we have to go 155 more. So we know this is going to be 90, and then we'll go just a little bit more. So maybe right about here would be our 155 degrees. But remember, the reference angle is the value of the angle that gets us back to the x-axis. So I cleaned it up a little bit down here. This is our 155 degrees, and we need to find out what this measure is. So if we know this is 90 degrees, and then 155 minus 90 meant that we had to go another 65 degrees, and we know that this is equal to 90 degrees. 90 minus 65 gets us to 25 degrees. All right, so remember our reference angle, you should put this in your notes, gets us back to the x-axis. Now we're going to look at radians. Okay, so it's important to remember that 180 degrees is equal to pi radians and 360 degrees is equal to 2 pi radians, and I labeled that on this coordinate plane. And we're working with 19 pi over 9. So if I had 18 over 9, I know that's equal to 2. So 18 over 9 pi is pretty darn close to 19 over 9 pi. So this is equal to 2 pi. So let's go around one time. That would get us to 2 pi, but we need just a little bit more. So I'm going to go up a little bit, and then I'm going to draw in my angle. Remember, the reference angle gets us back to the x-axis. It's the closest angle that gets us back to the x-axis. So we're only off by pi 9. I should say pi over 9, actually. All right, so now let's look at our final example. Our last one says theta equals 7 pi over 12. And I want you to remember that our unit circle, remember, is 2 pi, pi, and 1/2 pi, or pi over 2. So all I did over here on the left is convert it. So instead of 1/2, I have 6 over 12, and instead of just pi, I have 12 over 12, which is equal to 1. So 1 times pi is pi. So now if I go back up here, the reason I changed it to have a denominator of 12 is because that's what we're working with. So this says 7 pi 12. If we know that 6 pi over 12 is up here at the top, maybe 7 is here. So we can go ahead and draw in our triangle. And we know theta comes off the origin. Here's my right angle. So we need to find the difference between the 12 over 12 and my 7 pi over 12. And that is going to be 5 pi over 12, right? 12 and 7, the difference is 5 pi.